Elemental analysis is a scientific technique used to determine the relative amounts of different elements present in a sample. It is a fundamental method in various fields of science, including chemistry, materials science, environmental science, and more. Elemental analysis provides valuable information about the composition of substances, allowing researchers to understand the structure and properties of materials, as well as to monitor and control processes involving these substances. There are several techniques used for elemental analysis, each with its own principles and applications. Some common elemental analysis techniques include mass spectrometry, MS. Mass spectrometry measures the mass-to-charge ratio of ions to identify and quantify the elements present in a sample. Various types of mass spectrometry instruments are used, including inductively coupled plasma mass spectrometry, ICP-OES, and gas chromatography mass spectrometry, GC-OES. X-ray fluorescence, XRF. XRF is a non-destructive technique that uses X-rays to excite the inner shell electrons of atoms in a sample, causing them to emit characteristic X-ray fluorescence. The energy and intensity of these emitted X-rays are used to identify and quantify the elements present. Atomic absorption spectroscopy, AAS. AAS involves measuring the absorption of light at specific wavelengths by atoms in the ground state. The absorption is proportional to the concentration of the element being analyzed. Inductively coupled plasma optical emission spectroscopy, ICP-OES. ICP-OES uses an inductively coupled plasma to atomize and ionize the sample, and then measures the emission of light at specific wavelengths as the ions return to the ground state. The intensity of the emitted light is proportional to the concentration of the elements. Neutron activation analysis, NAA. NA involves irradiating a sample with neutrons to induce nuclear reactions that result in the formation of radioactive isotopes. By measuring the decay of these isotopes, the elemental composition of the sample can be determined. Combustion analysis. This technique is often used for organic compounds, where a sample is burned in a controlled environment, and the resulting products, such as carbon dioxide and water, are collected and analyzed to determine the amounts of carbon, hydrogen, and other elements present.